Hello everyone, welcome to your geometry review. Today we're going to go over Unit 1. Unit 1 is called Points, Lines, and Planes. You've learned a tremendous amount of information in Unit 1. And what I'm going to do is I'm going to start going over just the big topics that you have to know and understand for your test. And then I'm going to give you a quick overview of what those topics are. Once we're done with that, we're going to go straight into our study guide, and we're going to do questions that apply all of these topics and these concepts. All right, let's get started. First topic that I want to talk about is just the generic basics, points, lines, and planes basics. Now, in this topic, you have to know how to properly name them, so naming conventions and vocabulary. So you need to know the difference between a line and a line segment, or a line and array, or a plane and a point. You have to know the vocabulary. Additionally, you have to know what happens when these things intersect. So identifying the intersections. Does it form a point? Does it form a line when they cross? What happens? And then lastly, the segment addition postulate is a big concept in points, lines, and planes. So let's talk about these things. First of all, let me go over some of what these basic concepts are. So we know what a point is, okay? So a point is just a location, and it's always labeled with a capital letter. A line goes in both directions forever. It's infinite, and it contains millions of points all along the line. The way that you would name this line is you would name it by either a script letter that's in the corner next to the arrow. So maybe we'll call this line, let's say M. So we could call this line M. Or you would name it by 2 points that are somewhere on that line. So for example, if this was point R and this was point S, you would call this line RS with the line symbol above it to show that we're talking about something that goes infinitely in both directions. The next thing that I want to talk about is a plane. So a plane usually is pictured as a parallelogram. And the parallelogram, you'll see that there are different points on it. Sometimes they don't show you the points, but for what we're going to be looking at today, I'm just going to draw a couple of points on here. Do my best. Okay, so there are 4 points on this plane. A plane is just a surface. And the way that you would name the plane is you would name it by a cursive letter that's in the corner of the plane. I'm going to zoom in on this and I'm going to show you. If, for example, you had let's say a B, capital B in the corner of your plane, you could call this plane plane B. Or you can name the plane by any 3 non-collinear points that are on your plane. So we have 4 points right now. Let me go ahead and label them. So maybe this is point A, this is point T, let's say this is point C, and then this is point R. I can pick any 3 points that are non-collinear. So that means that they're not in the same line. So let me pick T, A, and R. I could also call this plane T, A, R. And the order of your letters doesn't matter. But those are the 3 basic concepts. Now, let's go back to see what else we have to know within this topic. The next thing that we have to know, after we've covered naming conventions and vocabulary, is to identify the intersections. So for example, and we're not going to go through all of them, but we'll do a couple. For example, if I have one line and then a line segment, so I'm throwing another vocab word at you. A line segment means it starts at a point and ends at a point. It is finite. It does not go on for forever like a line does. So let's say I have these 2 lines cross. My question would be, what is formed at the intersection? Intersection means where they cross. So right here, what's formed? A point is formed. It could be any point, or they could not name it at all. But let's say we did name it and we called it D. So these two items, this line and this line segment, cross at point D. They intersect at point D. Sometimes you have other things crossing. So for example, if I had a plane and then I had a line that's cutting through there. So imagine this is a sheet of paper. My plane is a sheet of paper. And I'm going to have a pencil that's going to go right through it. Right here, this line, which I'll consider my pencil, this line is cutting through the paper. It's cutting through the plane. And the question may also ask you, what's the intersection of the line, the green line, and the plane? And the answer, again, is it's a point right here, right where it punches through the paper. It intersects at a point. So let's say I call this point, make something up. Let's call it point F. Okay, so one more thing that I want to show you, and this may not be the best visual, but I will try my best, is what happens when two planes intersect. So let's say I have this plane here, and then I'm going to get a second plane. Okay, let's see. Let's get my Picasso skills out. Okay, so here I have two planes intersecting, the black plane and then the one that's slanted or diagonal, the blue plane. Now, the question may be, what happens or what is the intersection of these two planes? Well, this is where they're crossing right here. It's not a point. When two planes intersect, they actually intersect at a line that will go on for forever. Because the concept of a plane is that it goes on for forever. So imagine that this black and this blue plane go on for forever. That means where they cross will actually go on for forever. So the answer is a line. When two planes intersect, you form a line. Okay, so those are some of those basic concepts. And the last thing that I want to talk about is a segment addition postulate. Now, the segment addition postulate you're going to be using a lot. And you may not refer to it as a segment addition postulate because it's going to become so second nature to you. But this is what it is. You have a segment. So here's my line segment. So here's my segment. And there's going to be a point somewhere on the segment. So maybe it's here. And I'll call this A, B, and C. So for my line segment, I may be given pieces of information. I may be told that from A to B, it's X. And from B to C, it's, let's say, 6. And then they may tell you the entire length of the line segment is, let's say, 10. The question would be, solve for X, or solve for the length of AB. Well, whenever you see a line segment that's cut into pieces, you need to know that the left piece plus the right piece is going to equal the length of the whole thing. So in this example, I would set up an equation that basically says this. Give myself a little bit of room to write here. I would set something up that said, okay, the left piece from A to B, that's AB, plus the right piece, which is BC, would give me the entire thing. The left and the right equals the whole thing. And the whole thing is from A to C. And then I would start plugging in some values. AB is X, plus BC, which is 6. And that would give me the length of the entire line segment from A to C, which is that yellow highlighted section. And that's 10. Now I have an equation. With an equation, we can now solve for any variable. So if I were to solve this, my first step would be to isolate X, so I'd subtract 6 from both sides. And now I would have X equals 10 minus 6, which is 4. So the length from A to B is actually 4, or X equals 4. All right, let's move on. The next concept that you have to understand is midpoint and distance. There are some formulas and tricks for finding the midpoint and the distance, which we'll take a look at once we start doing some problems. There is a conceptual piece that you have to understand. For instance, if you're finding the midpoint of a line segment, here's my line segment. If I'm finding the midpoint, it would just make sense that my midpoint is in the middle, right in the center of my line. If I got an answer for my midpoint and it was not on the line whatsoever, I would have to have that conceptual understanding that said, that doesn't make sense. My answer does not make sense. If it's a middle point, it should be in the middle of the line segment. So that's what I mean by conceptual understanding. You should be able to check to see, does your answer make sense? Okay, so next, part C is finding the endpoint. So sometimes instead of finding the midpoint, let's say you were given one endpoint of your line segment, you were given the midpoint of your line segment, and they said, hey, can you figure out where the other endpoint is? That's a finding the endpoint problem. And we'll take a look at how to do that. Lastly, you're going to have to do problems where we apply this understanding. So applications. For example, finding the perimeter of an object or finding the center of a circle. First thing I want you to understand, if you're finding perimeter, perimeter applies the distance formula. Perimeter means if you have a triangle, or any shape really, could be a star, it could be anything. What you would need to know is you would need to know the distance between the first set of points on the left side, the distance between the set of points on the right side, and then the distance between the set of points on the bottom. In other words, the length of each one of those sides. So if this was, let's say, 3, this was 4, and this was 6, if I asked you for the perimeter of this object, you would tell me, to get the perimeter, you add up all the sides, 3 plus 4 plus 6, and you're going to get 13. So that would be my perimeter for this triangle. So perimeter is an application of the distance concept. Now, distance, you'll see in some problems, they'll just say length. They won't say find the distance between the 2 points. They may say find the length of the line segment. That's still a distance concept. Now, the other thing here under applications is finding the center of a circle. Well, just imagine you have a circle and you want to find the center of it. When I think center, I think middle. Finding the center of a circle is the application of the midpoint concept. If, for example, they give me the endpoints of the diameter, so they tell me this endpoint here and this endpoint here, and they simply ask me, what's the center? Well, that's the middle point here. All I have to do is find the midpoint of that line segment, and that is the center of the circle. So this is another application of this midpoint concept. Okay, let's move on to our last, we have 2 more concepts. So let's move on to our third concept. Okay, let's talk about partitioning. Okay, partitioning. I'm going to go through the 3 things that I've listed under partitioning. Finding the K value, conceptual understanding, does my answer make sense? And then using the formula and visual method to find my answer. So let's talk about what partitioning is. Imagine you have a line segment and you want to cut up the line segment evenly. Maybe you want to cut it into 5 even parts. So I'm just going to ballpark what that is. Let's say it's here, here, 3, so 1, 2, 3, 4, and actually the 5th piece would probably be here. So let me go ahead and fix my visual. Okay, so here is my line segment. I cut it up into 5 even parts. 1, 2, 3, 4, and 5. When I'm looking for our partitioning point, that means I'm looking for a point somewhere along this line segment where I've already divided evenly. So for example, if I want to put a point here, if this is my partitioning point, I have 2 sections on the left and I have 3 sections on the right. So what I've done is I've divided my line segment, I've partitioned it in a ratio of 2 to 3. 2 on the left, 3 on the right. The word 2 in math is also written with a colon. So you'll see that your ratios are sometimes given to you as 2 to 3 with a colon, just like that. Now, when it says finding the k value, k is a fraction. It's a fraction that represents a piece over the whole thing. So k is always the part over the whole. So for example, if I were to travel starting from the left point here towards my partitioning point, the part that I've traveled is 2. I've traveled 2 pieces, which is the first number here in the ratio, out of a total number of how many sections? Well, there's 5 sections, so the whole number of sections is 5. Notice that we get that 5 by adding the 2 pieces in the ratio together. So the way I got that 5 is I did 2 plus 3. That's how you find k. Now, for a conceptual understanding, part B here, I have to know that when I solve for my partitioning point, it should be on my line segment. If I got an answer that was, let's say, all the way over here for my partitioning point, that wouldn't make sense because it's not even on the line segment. How can it divide the line segment if it's not even on it? And now lastly, part C, there's different ways to solve for your partitioning points. And your teacher may have taught you a couple of different ways or maybe stuck to just one. I will show you once we get to the problems how to do it 2 different ways. There is a formula and there's also a visual method. So we'll see which one you like better once we get to the problems. All right, let's go on to the last thing that we have to know for our test. Equations of parallel and perpendicular lines. So first thing that you need to know before you can write the equation of a line is you need to know how to find slope. So slope, let me go ahead and zoom in here. So slope is given by the letter m. And if you have a graph, it's really easy to count slope. You just count the rise over the run. And you have to know if my line is going up like this, it's a positive slope. If it's going down, it's a negative slope. If it's just going side to side, that's 0 slope. And if it's going up or down, that's undefined. Okay, so I have my slope doing rise over run if I have a graph. If I don't have a graph and I can't graph points because I don't have a graph handy, what you could do is you could use a slope formula. y2 minus y1 over x2 minus x1. I like to always count my slope. Makes it easy, and it gives me kind of that visual check that I'm figuring out the slope correctly. Now, once we figured out how to get the slope and we have the slope, we need to move on to part B. It's just writing a linear equation. Now, we'll talk about this once we get to some problems, but when you write a linear equation, it should always be in y equals mx plus b format. It makes it easy because what you can do is you can see the slope right away when your line is in this format, and you can also see what the y-intercept is. So B is the y-intercept. It's where it crosses the y-axis. Okay, so we need to work on how to write a linear equation, which we will do some problems on. And lastly, C asks, or rather tells you that you should know how to determine if lines are parallel, perpendicular, intersecting, or coincide. Parallel, perpendicular, intersecting, or if they just coincide. If lines are parallel, like this, on a graph, that means they have the same slope. Their slopes are the same. Same slope. So if the slope of one line is, let's say, 2 over 3, Notice I kept it positive because this line is going up, so it is going to be positively sloped. Then the other line should have the same slope of 2 over 3 if they are in fact parallel. If this was off even by one little number, so if it was 2 over 4 or 2 over 5, nope, they are not parallel. Eventually they will cross. All right, so next, if they are perpendicular, let's do a visual for that. If the lines are perpendicular, that means that when they cross, they form right angles, corners. To be perpendicular, you have to have opposite, reciprocal slopes. Now, what does that look like? Well, opposite means that one should be a positively sloped line and the other one should be a negatively sloped line. So in my example, the negatively sloped line is this one here. So let's say my slope was negative 3 over 5. That's a slope for this red line. I would need my other line to have a positive slope. That's what the opposite piece means. And it needs to be the reciprocal. So reciprocal means flip your fraction. So instead of 3 over 5, it would be 5 over 3. So your slopes have to be opposite reciprocals. Now, if the lines are simply intersecting, meaning they're crossing, but they're not forming right angles, they're just crossing, they can have any other combination of slopes. So I'm going to do an example that may kind of trip you up sometimes. So for example, if I had this slope as negative 2 over 3 for my downwards line, and then the other one had a positive 2 over 3, those two slopes would tell me my lines are simply intersecting. Now, why? Well, even though they have opposite signs for the two slopes, they don't have reciprocal slopes, meaning the fraction isn't flipped. It's the same fraction, 2 over 3. It's just one's positive and one's negative. This would tell me that my lines are just crossing, and there's no right angle where they cross. And lastly, if your lines coincide, that just means that the two lines are on top of each other. So it's the same line. Maybe they gave you the line in two different formats, and once you put it into y equals mx plus b format, you realized, oh, they're actually just the same exact equation. The lines coincide. Okay, so those are your different choices. Now, we've talked about basically everything that's going to be on this test. Let's start going ahead and starting on a review sheet and going through the problems and making sure we know how to do every single piece of that review sheet. If we can do that, we're ready for the test. See you in a bit.